Okay, so now let's discuss how you draw the Q operating line. So the Q operating line is given by an equation of straight line, which is Q over Q minus 1x minus XFA over Q minus 1. So this is the equation of the Q operating line when you are given the condition of the feed. Okay, so there are many conditions of the feed that I have mentioned to you. Once the condition of the feed is given to you, you have to recognize that whether you are given the condition of feed, maybe all the feeds are in saturated vapor or they are in saturated liquid. So if there are a mixture of liquid and vapor, the value of Q is between 0 and 1. If the feed is saturated vapor, the value of Q is equal to 0 and Q is equal to 1 when your feed is saturated liquid. Okay, so when the value of Q is equal to 1 and Q equal to 0, you don't need to have this particular equation to draw your Q operating line. So bear in your mind that the Q operating line will be drawn starting from the mole fraction of the feed. So you just draw a vertical line of the mole fraction of the feed until it reaches the 45-degree line, and then you start to calculate the position of the y-intercept of your Q operating line. But if your Q is equal to 1, which is saturated liquid, you just draw a straight vertical line only. Okay? Or if your Q is equal to 0, you just draw a horizontal line beginning at this particular point. Okay? But the problem is that if you have a mixture of liquid and vapor, so you need to determine the value of Q so that you can substitute the value of Q inside this equation that given to you. Again, let me remind you, if your Q is 1 or Q is 0, you don't have to use this equation to draw your Q operating line. Only when your Q is between 0 and 1, then you need this equation to draw the Q operating line. Okay. Alright, so how do you calculate the value of Q? Because you are only have a basic idea on the value of Q when your feed is only mixture of liquid and vapor. And you know that the value of Q must be between 0 and 1. Okay, so just use this formula that I'm introduce here, where you just produce an equation of Q, where the first part of this equation represent the liquid part, and then the second will represent the vapor. Okay, so for the vapor, the multiplier is 0, but for the liquid, the multiplier is 1. If you're given in the question that only 40% of your mixture is in liquid form, therefore you just put 0.4 at liquid section. Okay, therefore automatically you know the rest of the percentage will represent the vapor. So by doing that, you're going to have Q is equal to 0.4. Okay, so with the value of Q is equal to 0.4, what should you do? Okay, so you know that your equation, your line will begin at this position. Therefore, you just need the interception of your Q operating line. So let's say we're going to substitute here, which is 0.4. So just take the value which is equal to negative XF A over 0.4 minus 1. So you're going to get a positive value because 0.4 minus 1 will give you negative value. So this negative value and this negative value will be cancelled off. So left with XFA over 0.6. Okay, so if you know that your XFA is equal to 0.5, well, let's say, so you're going to get 0.5 over 0.6, which is less than 1. Okay, so if you use your calculator, what should you get? 0.5 divided by 0.6, you get 0.83. So from your graph, find a position of 0.83. So the position might be this position. So I will label this in green color. Okay, represent the y-intercept of your point. Okay, and you just draw a green line here, starting from this particular point. Okay, all right. So next thing is for you to continue on. Once you have these two lines, you just connect the two lines. So maybe your EOL line is this way. Okay, I don't know. Okay, just assume. So therefore now, if you have your XB here, okay, so you just connect the line at the intercept between EOL and QOL. Okay?